Lesson 2.2, Standard Form. In this lesson, we'll look at graphing quadratic functions written in this standard form, and we'll determine key features. So far, we've seen quadratic functions written as a parent function and in vertex form. Standard form is when there are no parentheses at all, and it looks like y equals ax squared plus bx plus c. The coefficients a, b, and c are just numbers in the equation. Notice there are no parentheses, and this isn't going to show you in the equation what the transformations are. We have to actually do some calculating. When given a quadratic function in standard form, here are your key features. Step 1 is going to be the step that requires work. We're going to actually calculate the vertex. So we really can't tell by transformations when we're in standard form. To calculate the vertex, we're going to use those coefficients for a and b. The x value of the vertex is the fraction negative b over 2a. You'll definitely want to remember that formula. Once you know that x value, you plug it into the equation to calculate y. And then you write the vertex as an ordered pair, x comma y. The axis of symmetry is going to be the same answer as the x-coordinate of the vertex, and that's that vertical line. Make sure then that you include the axis of symmetry equation as x equals. The y-intercept is also super easy. We don't have to calculate it this time. It's just that last number in the equation. And then what you'll do is you'll reflect the y-intercept over the axis of symmetry. And that should give you enough information to graph your quadratic function. Let's try a couple of examples on the right. Example 1a. List the key features for the quadratic function in standard form. Then graph. F of x equals x squared minus 6x plus 10. Notice there aren't parentheses to help describe the transformation. Therefore, we'll follow our 4 steps on the left. Step 1. Let's calculate the vertex. To do that, the x-coordinate is found by taking negative b over 2a. When we look at the equation, b is negative 6 because it says minus 6x. That means we're going to have a double negative. That's a 6 right there, sorry. There we go. A would technically be the number in front of x squared, and since there isn't a number written, that defaults to 1. And then we just simplify. That double negative on the top would just make positive 6. 2 times 1 on the bottom is 2, so the x-coordinate of the vertex is 3. To get the y-coordinate, we plug that in. So we'll say y equals, where I see x squared, we'll plug in 3 squared, minus 6 times 3 plus 10, and simplify. 3 squared is 9, 6 times 3 is 18, plus 10. 9 minus 18 is negative 9, plus 10 would be 1. That's the y-coordinate. And we write our answer as an ordered pair, 3, 1. That's the most amount of work we'll do. The rest of the steps are pretty much free points. Our axis of symmetries, part 2. That's just the equation of that vertical symmetry line. And it always matches the x-coordinate of the vertex. X equals 3 is the equation for that axis of symmetry. Done. Part 3, the y-intercept. Remember, in vertex form, we had to actually calculate this. But now the y-intercept is just whatever that last number is that doesn't have an x. That's 10, therefore the y-intercept is 0, 10. And then what we'll do is we'll reflect that point. And we'll do that on our graph. Over on the right, let's plot 3, 1. And then we'll draw in our axis of symmetry right down through, mostly through, there we go, through x equals 3. And then we'll plot our y-intercept all the way up here at 10. So what I mean when I say reflect it, notice that the y-intercept is 3 units away from the axis of symmetry on that left-hand side. If I reflect it 3 units on the other side, there's my reflection point. Notice the vertex is down below. As we connect these points and go all the way down to that vertex and then back up again, notice our quadratic function, or our parabola, opens up. And that's because the a value is positive. All right, let's go ahead and try example B. Example 1b, list the key features and graph f of x equals 1/2 x squared minus 4x minus 3. Pause the video, see if you can use the formula to calculate the vertex. Once you think you have it, press play and we'll go from there. Did you get 4, -11? If you did, that's great. If not, let's take a quick run through as to why. If we do x equals -b over 2a, we would get a double negative on the top over 2 times 1/2. Well, if we make 2 over 1 a fraction times 1/2, the 2's cancel, and that's where you get just that 1 on the bottom. And 4 divided by 1 is 4. When you plug 4 in for x, think order of operations. 1/2 times 4 squared would be 1/2 times 16, and you get 8. Minus 4 times 4, which would be minus 16, minus 3. Therefore, the y-intercept is 4 negative, or the y-intercept, sorry, the vertex is 4, -11. A little bit off our graph, we'll try to make do. Step 2, our axis of symmetry. Now the rest of the steps are pretty straightforward. Again, that's the same as the x-coordinate of the vertex, x equals 4. Go ahead and draw that in. And then we have our y-intercept. And again, that's just the value of c, that last number, -3 on the y-axis. And then step 4, we reflect it. Notice now we're 4 units away, and let's go 4 then on the other side. Wow, so this parabola opens up again, but notice it's kind of stretched out a little bit more. So let's connect. Oops, I missed it just a little bit. There we go on the right. On both sides I missed it. There we go. Notice that's a little bit more kind of open from left to right, and that's because our a value is 1/2. So if the number is 1/2, it's actually compressing on the y-axis, making those y values kind of open up and be wider than the parent function. The last thing on this page, let's take a look at this domain and the range for this f of x. So we'll use that graph up above. The domain for quadratic functions is always -infinity to +infinity. That means you can plug in any number you want for x when you square it and then plug it in the middle and simplify. The range is going to be dependent on where that vertex is. Notice our vertex was down here at 4, -11. That means -11 is the smallest possible output. But then those arrows point up, meaning it goes up to +infinity. To work with quadratic functions in different forms, it's notable to show how to go from one form to another. Rewriting from vertex form to standard form requires these 3 steps. The first thing you want to do is take away the parentheses. So we'll actually write out the parenthesis twice since it's being squared, and we'll FOIL it. Then, to eliminate the parenthesis one more time, we'll distribute the a in, and that will get rid of our parentheses completely. Last but not least, our final step is we add k at the end, and that will convert from vertex form to standard form. Over on the right, rewrite f of x equals 2 times x minus 3 squared plus 4 in standard form. Step 1, we're going to write out the parenthesis twice and FOIL it. X minus 3 times x minus 3. So we'll do x times x, and that gives us x squared. That was an equal sign, sorry about that. And then we'll do, here we go, x times -3, which will be minus 3x. We'll do -3 times x, the inside, minus another 3x. And then -3 times -3 is +9. Combining like terms, we get x squared minus 6x plus 9. That now goes in place of the x minus 3 squared. So now we have f of x equals 2 times x squared minus 6x plus 9 plus 4. We've gotten rid of the squared, but now we need to get rid of the parenthesis. We're on our second step. Distribute the 2, or our a value, to all three of those terms on the inside. 2 times x squared minus 2 times 6x would be minus 12x plus 2 times 9, which is 18. Step 3, add that k value at the end. Notice there are two constants at the end. We're just going to combine like terms. Our final answer is f of x equals 2x squared minus 12x plus 22. And that's all you do to convert from vertex form to standard form. The last thing we'll do is we'll use the graph to interpret the quadratic function. Example 3. The graph of the function f of x equals negative 10x squared plus 700x minus 6,000 shows the profit a company earns for selling headphones at different prices. What is the maximum profit the company can expect to earn? What is the maximum profit? So notice on the x-axis, that is the selling price. And on the y-axis, that's the profit that they make. So it looks like it's somewhere right around that location at the top. That would be the highest point. To figure that out, that would be the vertex of our quadratic function. So let's see if we can determine the vertex, and that would give us that maximum output. It looks like it's pretty close to $6,000, but let's see for sure. To figure out the vertex, and we know we're in standard form, we would do x equals negative b over 2a. In this case, b is positive 700, so the negative out in front would make it negative 700. Over 2 times a, well, a is negative 10. Negative 700 over negative 20 means we'd have a value for $35. That's how much we would sell the headphones for. To figure out the profit, we have to plug that back in. Negative 10 times 35 squared plus 700 times 35 minus 6,000. Thinking order of operations, we should square the 35 first, multiply it by negative 10. However, if you carefully plug all of this into your calculator, you should get your answer without having to do individual parts. So try that. Grab your calculator, pause the video, literally type in negative 10 and then parentheses 35 and then squared. But not with the negative 10. Make sure your 35 is in parentheses by itself. Then you should be able to do plus 700 times 35 minus 6,000, all at once. Pause the video, enter that in, and then press play, and we'll see if we get the matching profit. We should get a total of $6,250. That's the maximum profit the company would make selling headphones at $35 a piece. So if the company sells headphones for $35, they will make a maximum profit of $6,250. The maximum profit is found at the vertex. And that's lesson 2.2.